Dear jury, dear audience, hello and welcome to our presentation. My name is Adrian.
And my name is Patrik.
And today we would like to show you our project-friendly DALEK, the autonomous robot. In the world of IT and robotics, there is nowadays a great focus on topics like big data, object recognition, and autonomous systems and vehicles. One of the key elements of autonomous vehicles is the ability to map their surroundings. To propose some of them are equipped with the LiDAR technology. Our main goal in this project was to create an autonomous-based vehicle that is capable of autonomous movement and mapping its surroundings. To improve the perception of our robots, we wanted to add object recognition capabilities to our robot that should recognize several important objects that are present in everyday situations and respond to them adequately. Our hypothesis was that the accuracy of the LiDAR and object recognition system will be reduced due to real environment and in movement compared to the simulation environment. The design of the robot is inspired by a character from the British series Doctor Who DALEK, and the main body of the robot consists of completely 3D printed components that are freely available. However, we need to modify those components to confess in our model. We designed the robot's chassis together with the component mounts in the Fusion 360 program, and then 3D printed them out. And after finishing the body of the robot, we had to solve how our robot will be able to function autonomously.
We use LiDAR, light detection, and ranging in the method for measuring distances based on the calculation of spreading time of laser beam pulse, which travel at the speed of light reflected from scanned object, which is evaluated in a photo detector. This distance is calculated by integrated microcontroller, whose calculations are based on the signal of main factor of return time. Our robot is using LiDAR H1M8 R5 two-dimensional LiDAR, which has maximum range of 12 meters. Depth shots of roughly 10 centimeters. The main factor of quality of LiDAR-based measurement is quality of reflection, which varies depending on the surface materials of surrounding objects.
On the bottom left of the picture, as you can see right here, you can see the basic view of the LiDAR measurements of the room that we are currently sitting on. And this measurement was done in the static position, which we considered a simulation environment. The picture on the right resembles the mapping of the terrain of the same room. However, on this picture in the program RP Vision, which allows us to store the mapped surroundings and even to project the path which the robot use if needed. However, we tested our system in real environment, as you can clearly see in the next video. The robot field of view is set, I'm sorry. Yes, the robot field of view is set to 60 degrees in front of him. That means it represents 30 angles on each side. And the objects that he detects should be less than 30 centimeters close, so the robot can respond to them. The robot is choosing direction that is opposite of the detected object to avoid it. As you can see, we put several obstacles in the way of the robot, and we change them to represent the differentiations and his adaptation to the terrain. As we already said, the essential factor for the accuracy of the LiDAR is the surface area of the object, and the flower pots that are glossy black have the worst
quality of surface.
The worst surface to reflect the laser back to its main board. So as you can see, the robot can withstand these difficulties, and the glossy black surface did a bit of irregulation. However, it could still withstand. The next problem was the problematic terrain. After further testing, we decided to prepare our robot to sudden changes in terrain below, such as stairs. The current design of the robot does not allow it to handle such problematic terrain, so we decided to solve this problem by adding IR sensors that they are the safety feature. We place those sensors below the chassis of the robot, and when they detect the empty surface below, they turn the robot back, and he backups, turn to appropriate direction as needed, and thus returning to the safe environment.
Objects, another key factor of our robot is object recognition. Object recognition is basically a comparison of learned objects with the objects that are presented in the system. For each item presented, the program calculates the similarity with learned objects and determines its relation in percentage.
The main equipment needed for this, however, is the quality camera that can produce a nice footage. For this reason, we are using Full HD camera Logitech C920. However, this footage has to be analyzed. This is done by our main controller board, which is Raspberry Pi. At first, we were experimenting with Raspberry Pi board 3, which wasn't, let's say, powerful enough to analyze the footage and was able to produce only 2 to 3 frames per second for a video recognition. This wasn't enough, so we choose the Raspberry 4 version, which has 2 GB of RAM and helped us improve to analyze the footage up to 5 frames per second, which meet our requirements. An object recognition software decided to use is open source solution that can provide us with customization options that meet our requirements, TensorFlow Lite. We decided to use pre-trained model from Google that recognize approximately 80 objects. And we programmed our robot to audio-visually react to several of them. So let's take a look. However, I would like to have some feedback if you can hear the audio of the video, because we had some technical difficulties before. Well, the first thing that we learned to our robot was a human, which is the most important thing to recognize. The robot must not cause no harm to people, so he avoids them. When it sees human, it asks for identification. However, it doesn't really care much, so he chooses a completely different direction to avoid any kind of person. The cables are only to display as how the robot sees as an output, but it is not necessary for a normal function of a robot.
Stop sign is basic element in the transport, and therefore it was necessary to teach the robot to react in the proper way. When robot recognizes the stop sign,
we're so close though. Yes, here we go.
And stops for a moment and to continue the way.
He adds a little comment and then he continues. The last but not least thing that we taught our robot was a teddy bear. This one is just a reminder that our robot is not just a cold piece of plastic. So we decided to detect and befriend some teddy bear animals. He do a little dance, greet his new friend, and then he continue in its path.
You would make a good DALEK.
As you can clearly see, he danced a bit, and he will continue as soon as possible. So for a conclusion, our system for autonomous robot operation in its current body can find use, for example, as a piece of a teaching equipment for understanding the functionality of LiDAR and terrain mapping and demonstration of one of the basic elements of the AI, which is AI vision. Thanks to its eye-catching design, it has power to attract the attention of the students, which can have possibly an interest in those topics. However, its further use can differentiate a bit more, and it could be more complex when the whole system can be transferred to another body or a vehicle, for example, and still be capable of normal function. The complete robot, its current body weighs about 3 kilograms. It's 45 centimeters high, 30 centimeters long, and 25 centimeters wide. On behalf of both of us, I would like to thank you for your attention and for our mistakes and for problems and technical difficulties that we have. And if you have any questions, we will be happy to answer them. Thank you.
Thank you. I will try the virtual background again, but it's very tricky. Oh, I think, oh, now. Okay, now it's okay. Okay, we will end the presentation. Now you can see us.
Thank you very much. Are there any questions?
Okay, I have a question. Thank
Hi.
you for the presentation. It's a good project. Could you please answer what is unique thing for your project? Because, for example, there are many educational tools that can be used by students. There are many toys like this that can interact with objects, with people. Vacuum cleaner can make a map of a room and avoid objects and so on. So all these functions are already realized and already used by different robots for different applications. So what is
Well, I have to agree that all of the technologies are already used, for example, in vacuum cleaners. However, we wanted to try to focus our project on the, let's say, the explanation of the LiDAR technology, because it's not very common in here in let's say in our country, and you don't have most of the time the access to such technologies even in the vocational school as we do. So we tried to make something to show this technology that most of our, let's say, people in our age didn't even heard of, and we talked about this a lot. And the most, I think the best thing was that we were able to obtain a semi-quality LiDAR sensor that helped us a lot with measurements that have a bit of a precision.
Yes, we are using not high-end components, we are using low-end components to.
So we try to make it affordable for
Yes.
example, for schools as ours, because this will be the part of the teaching equipment for our school.
Yes, for example, price of these robots can be low as $200.
But it depends, because the main, let's say, expense comes from the design, because it has to be eye-catching for students from lower grades. So, for example, when you think about the small children, or not even the small children, for about the, let's say, about 15, 14-year-old child, it can be a box with, or a vacuum cleaner. It is not that interesting when you see a vacuum cleaner, which is, you know, it's nowadays, it's something that is common in some areas.
So your project is an educational tool for school?
Mostly in this design, yes.
Okay.
However, the system can be transferred to something different, and we are planning to, let's say, build a second model, a second version, which will be mostly different in the way of the meaning of the type, how it is even moving, because this is a two-wheeled.
Yes. For example.
Yeah. Stop. Let him go.
Yes. Let me make a small comment. Please think about users' experience. So how it can be used for small grade students or high grade students. So how it can be used in different educational purposes.
Well, we have in our school, it is a quite new subject. It's called robotics, and it is I think its main use is on the lessons on the robotics, because when you can work with such technologies that you cannot before, so I think it's mostly for that. For example, for our school on the subject of the robotics.
It can be programmed in Python, for example.
Well, it can be programmed. You can work with the mapping of the terrain to saving the maps and work with the maps, and even program and prepare the different ways and taught the robot the most different techniques how to avoid some objects in the way. You can thought in more. That's the point of this robot, that is it's an educational tool, and it can be let's say it has many ways to be improved by students.
Okay.
And to work with it.
Did you think to make it open source project? I mean publicly available with 3D model and some description and documentation?
Yes, we were thinking about this. However, we would like to expand our project to like object this as a version 1, and then we would like to hop to version 2 that will be a bit better for public, to have a better documentation to produce it, because this already has some documentation, but it's not good enough to be, I think, open source to be. It could be modified a bit to be open source for the public. And the best thing to being open source for the public is that the public can improve it even more. So yes, we are definitely thinking about it, and we will probably do it very soon.
For example, model must be easier to print.
And even some mechanical parts that we are, for example, the chassis should be or must be a bit easier to print and done.
Thanks for questions.
Guys, thank you for your presentation. It was really interesting. My comment is most related to the Artem questions. So I also had some question to you about the novelty of your research. But now I understood that you're mostly focused on some educational tool, and if it's right, then you should develop, some educational platform to this device. Not use it only as a robot, but together with some educational platform, and it will be really useful.
Yes, that's the future plan of the, let's say, some kind of an application that will help students from mostly the lower grades to work with it easily, because it tends to have some knowledge in, for example, in programming and in electronics to work with it. But that's why we want to make it, let's say, free for the public later to improve this to. It can be more easily workable from the not, let's say, professional public.
Thank you.
Thanks a lot.
Thank you very much.
Thank you.
We have to move on to the next project.
Thank you for your attention. Goodbye.
Goodbye.